Hello students, welcome to my YouTube channel. In this video lecture, we are going to solve questions from sample paper number 7, RK Bali navigation book. I am going to solve questions from 31 to 40. So, question 31. More fundamental function on causing stall warning is what? Okay, so what is the fundamental factor that causes a stall or a stall warning? High speed, high angle of attack, low true airspeed. So correct answer is high angle of attack. Whenever you exceed the critical angle of attack of your aircraft, stalling will happen. Okay, so here you can say angle of attack is 10 degree. As the angle of attack increases, okay, angle of attack is nothing but the angle between the longitudinal axis of your aircraft and your path, flight path, the direction in which you are moving. So as the angle increases, soon when you cross that angle threshold, okay, critical threshold angle of attack, critical angle of attack, stalling will start happening. So the most fundamental function causing stall is the high angle of attack. Next. Aircraft is at 24,380 feet at a range of 30 nautical miles. What is the indicated range? So your DME will always show slant range, will always indicate slant range of your aircraft, right? So let's say, let's draw this triangle. Here is your DME station. This is your aircraft. This is 24,380 feet. Horizontal distance is 30 nautical miles. We have to find out the slant range. So, apply Pythagoras theorem. What is Pythagoras theorem? X square will be equal to 24,380 feet. Convert that into nautical miles. 24,380 divided by 6,000, approximately 4 nautical miles. So 4 square plus 30 square, 16,900. So x will be equal to root of 916. So root of 916 is equal to 30 nautical miles. 30.2 nautical miles. So the indicated range will be similar to the horizontal range. Okay. Next. Due to emergency, the pilot descends at a great vertical speed. What will he expect? Greater ground speed, longer roll landing distance, undershooting of runway, greater airspeed, longer roll distance, proper control of aircraft, greater ground speed, long roll distance, overshooting of runway. So correct answer is option alpha. Now whenever aircraft is descending at a very fast vertical speed, the aircraft will gain ground speed, speed with respect to the ground. Greater ground speed means great momentum, great kinetic energy, and it will take a longer landing roll or landing distance in order to get rid of that extra energy. And you will undershoot the runway since you are descending at a very fast rate. Okay, so there can be a problem of perception, and since it's an emergency situation, you can end up making some miscalculations which can lead you to which can lead in your undershooting the runway. Okay, so alpha. During the approach, a crew reads on the radio altimeter 65 feet. This is an indication of what? So radio altimeter indicates the true height of your aircraft with respect to the ground surface. So if this is your ground surface, radio altimeter will indicate the height from your aircraft to this ground surface. Now this height is nothing but with respect to the wheels of your aircraft, the main landing gear of your aircraft, from the main landing gear to your ground. So height of aircraft with regard to ground at any time, height of the lowest wheel with regard to runway threshold anytime, height of the lowest wheel with regard to ground at any time. So option Charlie. Now the runway may be in front of this aircraft. So the Vertical distance reported by the radio altimeter will not be with respect to this threshold. It will be respect to the ground directly below your aircraft. Okay, next. The altimeter consists of one or more several aneroid capsules located in a sealed case. The pressure in the capsule and the casing are what? So this is the uh, back case of your altimeter instrument. You have this aneroid capsules, and this aneroid capsules are inside this instrument case. Now these aneroid capsules are filled with vacuum or very little atmospheric pressure, and the surrounding environment of the capsule is gets filled with outside ambient static pressure. That outside pressure enters through the static port inlet. Okay, so the pressure in the aneroid capsule is very low and the casing is static. So option A. 36. The initial climb for a single engine aircraft. So they are talking about single engine aircraft. Initial climb, beginning from takeoff involves Vy, rate of climb speed followed by angle of climb speed followed by rate of climb speed, best rate of climb speed initially followed by best angle of climb speed. You will be so since it's a single engine general aviation aircraft, it will first fly at Vx, best angle of climb speed, and then it will increase its forward speed to a best rate of climb speed. Now this best angle of climb speed will be flown at in order to clear all the obstacles which are at the end of the takeoff runway. Okay, what is best angle of climb speed? It is that speed with which you can climb to highest level in shortest horizontal distance. So short as possible, the shortest distance you are climbing to as high as possible. What is best rate of climb speed? You are climbing to a particular level in the shortest amount of time, quickly. Okay, very quickly. So first you will fly at angle of climb speed and then you will transition to best rate of climb speed. So first clear all the obstacles and once you are at a safe altitude, begin your rate of climb speed. Next. What does the turn coordinator indicate? So it indicates your rate, okay, around vertical axis. What is the true direction and distance from point Papa to point Quebec? So both are located at same longitude, okay. So let's draw that. So the longitude is 57 degree 09 minutes east. Papa is here at 48 degree 30 minutes south. So since it's the south hemisphere, Papa will be here 48 degree 33 minutes south. Quebec destination will be here 71 degree 23 minutes south. So this is a great circle distance, right? What is a great circle track? Your meridians of longitudes are great circle tracks. So when you're flying between 2 points located on the same longitude, you're flying a great circle track. So it is d lat in degree into 60. What is the difference between the two latitudes? 71 degree 23 minutes minus 48 degree 33 minutes. So it is 22 degree 50 minutes multiplied by 60 is equal to 1370 nautical miles. You are flying a constant compass heading of 252. Variation is 22 east. Deviation is 3 west. And your drift is 9 degree right. So let's find out true heading first, and from that true heading we will find out true track. So deviation west compass is best, meaning compass will be more than magnetic. So magnetic will be less than compass by 3. So 249. Variation east magnetic is least, meaning magnetic is less than true direction, right? So true will be more than magnetic by 22. So it is 271. So your true heading is 271. Drift is 9 degree right or 9 degree starboard. So starboard drift, heading is less than track. What is heading? 271. Track will be more than heading by drift. So 271 plus 9, 280. That is your true track. Next. Which band does radio altimeter operate? It operates in the super high frequency band 4.2 gigahertz to 4.4 gigahertz. That's it. So this concludes the lecture. I hope you have understood all the 10 questions I have answered in this video lecture. Thank you for your time. Best of luck. May all your dreams come true. In the next video lecture, I will solve the remaining questions. I'll see you there.